verifying trig identities totally happen in chapter 5.
Oh, that's right.
But I'm curious, can you tell me anything about that?
You have to use trig identity to verify.
Oh, you have to do the T.
Oh, nice. T-proof. You were right, Sophia, like we could break down the words, but like a quick reminder for everybody is like the T-proofs. Those were verifying trig identities. If you don't like it, you can make a friend and pass it off to someone else. T-proofs, right? And T-proofs, well, no. I can't give you answers. I have so much more candy to get rid of. So, something else. You can keep on building on that. You can go a totally different direction. You can tell me what section that happened. Izzy.
You have to write the equation.
Oh, you tell me the first step. Yeah. So the T-proof, we have an equation. Can I say to be true? Is that okay? You have an equation. And with that equation, yes, you write one side and you have to finish until a check mark. Oh, some of you could have gotten candy on the check mark. But you start with an equation, right? And you have to pick a side and go all the way down and show why one side's the other. That's the T-proof. Okay, something else. Alex.
The Pythagorean identities.
Oh, we have identities. Can I just generalize that? So we have all of these old.
I'm sure colored.
Let's not use the word old. An old student, a former student, was working in Washington, D.C., and one day he made the mistake of saying the word old, and let's just say his very liberal congressman's office that he was working for, like, crucified him. He was never allowed to use the word old again. Elderly is okay. Old enough.
You can say boomer.
Foundational. There you go.
Yay, word.
Words are power.
Depends on my say.
Actually, it's interesting. My pastor said this past week. Not that words are power. He said that. Clarity? Confidence? No. I have to look at my notes. No, it's not careful. That's no fun. You can step out and say it. Sometimes it's a fun adventure. I think it was clarity. Clarity is power. I'll look it up and get back to you on that.
Knowledge is power.
Anyway, only if you use it.
Mega mind.
So, hold on. Alec, you were getting us started.
Yeah.
Pythagorean.
Mega mind.
Give me a Pythagorean, because you just remembered it.
With sine squared x minus cosine squared x equals wait.
Someone help him.
Sine squared x plus cosine.
Equals?
1.
So, we have identities. There's a whole big old chart. Someone find it for you, me, or the whole class in your notes. Where's the huge old chart?
I found it.
Where is it?
5-1.
Good. So we have all these old identities that we were using. Okay, someone tell me anything else. I have so many more things.
The reciprocal.
Megan. So this one was section 5.2. But before section 5.2,
No. That was in 5.
there was section 5.1. In section 5.1, they didn't give you an equation. You weren't showing it to be true. They just gave you like a block of stuff with trig and said simplify.
What?
Maybe a factor, maybe a solve, maybe a... What else did they say besides factor? Factor and simplify. Maybe you did get some. Factor, simplify, plug in, substitute. I think that was one. What else? Common denominators. Oh, I'm just giving stuff in there. Alex, what else?
The co-function identities.
Oh, you're just going to start naming them. There's a system now.
Oh! Look the way. Kid.
But, Alec, if you tell me the co-function, you got to give me a co-function identity.
Sine times pi over 2 minus 3.
Oh.
Good. Sine of pi over 2 minus, and it could be cosine of pi over 2 and tangent of pi over 2, and all of them have co-functions, the weird pi over 2 ones. Caitlin.
I was going to say, other than factor or common denominator, just adding factors or
Nice.
squaring binomials.
Good. So with these ones, everything's simplifying. Remember some of the skills, some of the math, like the old math? It was like, hey, can you factor the trig? Hey, can you do common denominators? with trig, hey, can you, let's do slashes. Can you combine fractions, which needs common denominators? Can you, what did you say, like FOILing, squaring?
Squaring binomial.
Oh, we could do like polynomial operations. Does that sound good? It's like anything with binomials, trinomials, etc. Priyanka, you found something. What did you find?
The even and odd ones.
Oh.
Yeah. What's an example of an even odd one?
Negative cosine theta is actually, it simplifies to positive.
Those are the nasty sine of negative x, cosine of negative x, tangent of negative x. We can do something with those identities. What else? Izzy?
Quotient identity.
Ah, give me one of those.
Tan u is sine u over cosine.
Okay. And then there's also, who else is in there? Tan. Oh, and there's like, yeah, there's other yucky ones as far as like secant is 1 over cosine, which whoever does that. No. Cosine is 1 over secant.
That's the reciprocal identity.
Oh, those are reciprocal those.
It's not.
Okay. Oh, the other quotient one's cotangent. Huh.
Quotient is tangent, cotangent, reciprocal is sine, cosine.
Nice. What else do you have, Alec?
Let's see.
Although you got reciprocal, I mean, Izzy did too, but
Yay.
we'll get a kiss for it. There you go. Anything else?
Get out of here.
Ow, my knee.
Anybody else? Anything else? 515253.
Oh, different forms of Pythagorean identities.
Ah, all of our identities can be rewritten. Like tangent squared of x could be sine squared of x over cosine squared of x. We can use a quotient and use it like by squaring it. Or we could say sine squared of x is equal to 1 minus cosine squared. You can rearrange them. But what is something no one has said? How about section 5.3? Inverse trig. We had to go backwards? When did that happen? Inverse trig.
Bruh. With the graph.
I don't think we really had to use graphs in chapter 5. Inverse trig, it was more something like this.
Oh yeah.
No, there's no inverse trig. That's just sine. But what are we supposed to do?
Arc sine.
Yeah, think arc sine or sine inverse of both sides. And when we think inverse trig, what do we have to remember? That's something still no one has said. And anytime you say trig, it's always involved. Unit circles. 1, 2, 3, 3, 2, 1. Square root of 3 over 3, 1 square root of 3. Where's sine in that whole table of the 1 and the 2 and the 3 and the 3?
The top.
So, Toa, right? So, when is sine 1/2? Who's this guy? Wait, is that the only answer?
No.
Depends on what they ask. Go find section 5.3 from your notes, and I want you to look at the very, very beginning. We talked about, based on the directions, what answers you give. Could this be an answer? Yes.
Oh.
If they want you to only find the one, but what if they want you to find more than one?
Plus 2 pi.
Let's say, they say between negative 2 pi and 2 pi. They say that. Sophia's not quite right, but she is good, and that is something. That's just not this answer. So we'll get back to the whole plus 2 pi n thing in a second. That's infinitely many. Are there infinitely many places in these angles? No. So
Negative.
where is sine positive? First quadrant, because everyone's positive, right?
Yes.
Where else is sine positive? All good. And
Students.
who's this angle? That's pi over 6. Who's this one? That's 1 pi over 6. Oh, whew, I'm done. No, I'm not done. I'm not done. Because all I did is go to 2 pi, right? 1, 2, and then no more. Because those are all negative. But what else am I supposed to be going? To 2 pi, but also to negative. Oh, what would these angles, Hurricane be what angles would go the other direction? Gee. You guys agree? So I have to go -6 and one more, and then -12 but one fewer to get the other ones. Now, Sophia, can you tell me about that whole 2 pi n thing you were saying a second ago?
When you're solving tree equations,
You're solving tree equations.
and you have no limit.
And I have no limit. Good. Solving tree equations. They haven't told me any directions to limit it or say only find these answers. It just says find. Usually the word is all. Good. All solutions. That's infinitely many. At that point, we can say take this guy and take that guy. Now sometimes this can look weird because they're mathematicians, and if they can figure out a way to take separate and put all together in one nice, neat, tidy equation, they will. So sometimes the answers will look a little funny. But whenever we see the word all, we just go look. Did anybody find anything else that we didn't go over? I still have technical freedom.
Let's see.
5-1, 5-2, 5-3. Anything we
Oh.
haven't talked about?
Always try to factor.
That's a stretch.
And add. And I can't really.
You're thinking like see-through steps, right?
Yes.
Can we change that to always try something?
Yes.
Because that was one too. And even if you, because even if you get stuck, always try something. That's a good one. Let's say these two, and let's at least start 5.4. Because even though I technically have the homework due on Friday, and I have our calendar kind of spread out so that we have extra time, etc. I think technically we're supposed to be starting section 5. Oh, come on. My computer's been super mad at me today. Section 5.5 on Thursday.
Suppose I disobey.
Yeah.
Okay.
But we will have started the next section when this homework's due. I'm so sorry, kiddos. My computer's totally frozen, so let's just give it a second. But as we give it a second, why did I just spend so much time of class just talking about 5-1, 5-2, 5-3? 5-5-5. What do you see coming in 5.4? And Jaden, what were you like, man, I can't see that. What is all that stuff you're trying to get?
Sum and difference formulas.
New formulas.
Yes.
Because
So why did I give out individual kisses to all the people who were just reading the table of identities from before? Are all of them important? Yes. But what's going to happen in 5.4?
Memorize them.
Now there are more.
are we going to be able to put them on like a card?
And what's going to happen in section 5.5?
More.
There are more.
So no,
Now, did Jaden just ask an excellent question?
maybe so.
Because we have a whole table. Here's another whole table, and I just hinted that there are other tables coming. Would it be nice to be able to do any of these problems, 5-1, 5-2, or 5-3, with a whole big old chart of formulas in front of you? Yeah. The only dilemma is, do you think I think these formulas are kind of important? Okay. So, think like a teacher for just 1 second. If I think, as a teacher, formulas are super important, but I understand that when you're trying to do a problem and you have to remember a formula, will stink. Even if I know how to do the problem, if I remember the formula wrong, I might get the whole problem wrong. How could I try to consider both perspectives when a test is coming? Formulas are important to know, and yet I understand it's helpful to not have to recall them when doing problems. Have formulas be separate. How could I, as a teacher, make the formulas separate from the problems? 2 parts to a test. Could I maybe have like a formula quiz one day and then give you all the formulas the next day for the problems?
What do you
And
mean?
then you could study them separately and have a little bit of space in between. Meaning, there's going to be a formula quiz the day before the test. Our test review is, I think, kind of like 2 days long in the sense of we're going to have, oh, that's on the calendar, stink. Sorry, I don't have it memorized off the top of my head. The day of the test, is only going to be problems in your formulas. All the formulas, at least all of the complicated formulas, are going to be printed on a sheet that you can use. Okay? So anything to do with simplifying or verifying or solving, those are the three main directions you can be given for all of Chapter 5. Simplify, 5.1. Verify, 5.2. Solve, 5.3. You're going to have formulas for any of those. But the day before that is going to be a big old giant fill-in formulas. Fill in like what? Well, I'm going to have the categories all written out, kind of like the tables have. So for instance, I could have sum and difference with sine of u minus v equals, and a big old blank you fill in. I could have quotient with tangent of u or tangent of x or tangent of theta, whatever, equals, with a big old fill in. Now, help me out a little bit. What if I did have quotient and tangent of x equals with a big old space? What would you guys fill in to get 100% on that question? My visual ones. No stress, I'm going to write it. What if the label was quotient and I had this written? Yeah. What if you just do sin over cos? But if you do x and x? 100%. Now, could I do both of them?
Plus u.
Sure, you could fill in both. But do some of the categories have like 6 different formulas? Am I going to have you fill in all 6? I'm going to pick and choose. Things like the reciprocals or things like the Pythagoreans. Like I'll just have 1 or 2 or 3, but I'm going to have the category written, and I'm going to have one side of the equation written, and you just need to fill in the other side. And based on the category, you should know how to fill it.
If it's 2 parts, is it 2 separate grades or just one complete?
2 separate in the sense that the formula portions were 25 points and the problems are worth 75 points, but I'll put it in as one chapter 5 with a score of 100 points. Does that make sense? So, questions on what's coming? So, what could you start doing tonight if, in some ways, we don't really have homework due for a while? Yeah, flashcards, Quizlet, believe me, trig identities, it's a thing that kids all over the nation have to memorize. Someone's probably already made things for it, but couldn't you go through the old ones, the ones in 5.1, the new ones 5.4, and even look at the future ones 5.5 and get them all written out and start studying? And what's going to be helpful is that if you have these formulas memorized, if we get to problems and you need to use them, hopefully they'll just be popping into your brain. As to like, oh hey, I can make tangent sine over cosine. Or, oh hey, I can make secant 1 over cosine. Or, oh hey, I can make sine squared plus cosine squared 1. So it's going to do double duty. It's going to make your homework go faster if you're memorizing these, so you don't have to keep on looking them up. But you can, when you're doing homework, you do not need to try to recall the formulas because you're going to have them in front of you. So totally just have them written in your notes or write them out on a big old page for you to study. You can do that too if your brain works better that way, by covering one side and trying to fill in. On the formula portion, I'm going to give you this side, the left side, and you fill in the right. I'm never going to switch it around. I'm going to give you the left, and you're going to fill in the right. But in problems, you might need to work backwards, so have the formulas in front of you whenever you're doing problems, okay? Well, I'll have to say, well, stink, if we have to memorize these, have the ones that we've had to memorize so far been really weird, like really complicated? Out of those fundamental ones, does anybody have like a certain category that's probably going to be hardest to remember?
Pythagorean.
Yeah. For most people, the Pythagoreans are the hardest to remember. Now, not the sine squared plus cosine squared ones. Most people get that down pretty easy. But the ones that get nastier, like the 1 plus tangent squared, remember who he equals?
Cosecant something.
The C's go together. Sorry. He goes with the other guy. Who's the other guy? Okay, those are tricky to memorize. But do you see how we have a whole new table and they're kind of like brand new, and how am I going to memorize these? Can I give you some tricks? Now, can you make up your own way of memorizing? Yes, you are juniors, seniors, and you're already doing fairly well in school to be in an honors pre-calc class, right? Okay, so you have different ways of memorizing. So think about that as you're going here. But pause. Does anybody see see patterns? If you see patterns, and if you can understand and know and memorize the pattern, maybe you don't have to memorize 6 different brand new formulas. What do you see in patterns?
Sinusoidal.
I don't know if the waves will really help you studying, but why am I doing this? You're not really memorizing 6, you're memorizing 3. Why?
They're the same thing with the sign change.
So first of all, if I can get these figured out, these, oh hey, the signs change. Can I help you with knowing who's who? Co, we talked about last semester, means with or together. How can that help you with these? What's with or together in the cosine ones? This is something different.
Both the cosines are together and both the sines.
Co, sine, sine. Co, sine, sine. With the cosines, with or together, the trig are together. The trig are with their corresponding trig. But sine, they're not, right? So cosine, they're with or together. Co, sine, sine, co, sine, sine. With sine, sine, cosine, cosine, sine. That's one way of remembering which one's which. But you can also say that with sine, the signs stay the same. What do I mean by that?
Yeah. And cosine, they change.
If it's a sine of a sum, it's a sum. If it's a sine of a difference, it's a difference. If it's a cosine, oh, they change. Now, is this necessarily the most efficient way for some of you to study these? No, but has it worked for me? Yes. Co, with or together. Co, sine, sine. It's the way I remember it every year. Sine. The signs stay the same. Sweet. Plus, plus, minus, minus. Cosine, they flip around. Now, can you see anything with these that would help with down here?
It's just a combination. One and one.
Not the same thing, it's just the signs are switched.
Well, I have one same and one change. Man, I wish there was a way for me to use this same and change and who's tangent? Quotient property. Use it for a second.
Sine x over cosine.
Sine over cosine. Oh! Same over change. Ha! Sine, tangent is sine over cosine. So since tangent is sine, now could I technically take this big old sine and take this big old cosine, and I could actually do some crazy math, and I've done it in years past when I've had lots more time. I can actually take the sine of the sum and the cosine of the sum and show you where the tangent of the sum comes from by basically multiplying by a conjugate, top and bottom. But it's a mess and it's ugly and it's gross. So instead I just say, you know what, tangent, remember how he's a sine over a cosine? That's gross. An opposite over an adjacent, however you want to think about it, the quotient property. Same over change. Check it. Same over change. Yes. Wait, cosine. Who is he?
Together.
Where's the tangents?
Together.
Where are they together? In the sine over, in the cosine part. Where are they separate? In the sine part. Okay, it's not perfect. I don't know. But what am I trying to help you guys do now before we start the rest of the chapter? Play with your formulas and try to figure out ways of memorizing study. Whether it's Quizlets or flashcards, or whether it's writing out a big old, like writing it out or typing it out a big old sheet with all of the formulas together, and then trying to figure out little different devices, little different techniques of how to memorize. This is the one day I'm going to spend time on this. Everything else, it's like, sorry, new formulas figured out. New formulas figured out. And the nice thing is, I'm not going to make you memorize all of them. When we get to section 5.5, I'll be these, memorize these. These, memorize these. It's okay. We're going to use them all. You don't have to memorize them all. But these ones, if I'm telling you how to study them, what do you think is coming? They're going to be on the quiz. Okay? But, help me out, cool kids. From everything we've done today, can you look at what's coming underneath the big old table of new formulas? What do I say? Can be useful, or can be used, these can be used, like the old ones, the elderly ones, the former ones. To do what? solving section 5.3? But with just the former identities? Wasn't verifying section 5.2 just with only the former identities? Wasn't simplifying section maybe both of these? The directions are going to be the exact same. That's why it took so long to review. What's new? We have some new tools in our tool belt. We have some new formulas that we might need to use. But the directions, nothing's going to change. So here's the crazy thing. Ready? Guess what's coming for the rest of section 5.4?
Oh,
Oh my goodness! What do you not see?
anything else?
Wait, section 5.5. I know there's more. What do you see in the first page?
4.
Formulas. And then examples, examples. Oh, formulas. Oh, examples, examples. Formulas, examples, examples. Formulas, examples.
Get out of here.
Formulas, examples. So wait a minute. Is there anything new as far as what we're doing? No. All that's new is what?
More.
Formulas. Does that make sense? So, can we just maybe do one or two examples to finish off today? What if you see something like evaluate? Is that a T-proof? No, because what word would be there for a T-proof? Verify. Okay, forget that. Oh, are we simplifying? Maybe. Are we solving? There's no equals. No inverse trig. So what do we do?
You just like put in the simple formula.
Well, you just do it. How do you do it? Well, it's unit circle stuff, right, guys? So isn't this one the easiest one? Because that one, like, do I use a formula or do I just put it together? Who's sine of pi over 3? 1, 2, 3. You guys agree? Yeah. 1, 2, 3. Yeah. Who's sine of 7 pi over 6? All students take calculus. Uh-oh. Okay, it's a negative number. 1, 2, 3. Oh. How do I don't know. Negative 1 minus root 3. I can combine my terms. I mean, I can combine my fractions because there are common denominators, but do I know what that is? Nope. Well, then how do I do this one? I don't know. You guys want to think 10 bucks? Yeah. Can we actually, like, subtract two fractions? Yeah. We can make this a common denominator by making that 2 over 6, and what's 7 minus 2, that's 5. Is this a new unit circle guy? No. Do I need my calculator, or can I use unit circle? Yes. Oh. All students, it's a positive. 1, 2. Well, that was dumb. What was all that all about? That had nothing to do with anything new, or did it? Question. Is this answer the same as that answer? No. So what's the main point of this weird just using the unit circle? Why am I putting this and making a big deal about it?
Not equal.
Why would you ever think they're equal? What are some of you going
Distributing
to
into both.
What's the only legal way of solving? Is it distributing the sin? No. It's, isn't this a sine of u minus v for me? So if I wanted to actually solve it, either I have to go straight forward, or if I ever wanted to rewrite this, I can never just distribute the sin. Instead, I have to do, wait a minute, sine. It's not with or together. I need to use, you have to. It's the only legal way to rewrite it if you ever needed to. Do we need to rewrite it here? No, it's fine. But in the future, if you start putting x's in, the only way to rewrite it is using the formula. I can't distribute sin. That's not the legal way. The legal way is, I have to memorize. I go through and do it the hard way, and it would work, and it would be 1/2, but who wants to do it the hard way? I'll do it the hard way, as you guys look at, well, what's the big deal with that? Why would they say find sine, cosine, and tangent of the angle, and why would they show me this? I don't get it. Like, whatever. This is something we did in chapter 4. Just take the sine. Take the cosine. Take the tangent. Why are they showing me that that guy comes from this guy if you do like common denominators and stuff? And I don't know, I guess multiply by 3, and I guess multiply by 2. And 9 pi plus 2 pi is 11 pi. Okay, fine, it's true. What's the big deal? Just go to your unit circle. Can I go to my unit circle?
Yeah.
No,
For 12?
it's not.
Oh.
It's not gonna work.
Unit circle is only for who or what?
Oh.
Sixths. What else?
Yeah, but isn't that?
Fourths,
Thirds.
thirds, halves, pies.
Yeah, but isn't
What?
that a little less than 1 pi?
Yeah.
But
I mean,
it's not-
I could draw it, right? Like, if this is 11 pi over... No, sorry, this is 5 pi over 6. 11 pi over 12 would be like...
Isn't that good?
No.
But whose sign? They want me to
Oh.
find it? Like, I can draw it. Yeah, you're totally good. I can find the supplement to it. It's pi over 12. I can find the reference angle. It's pi over 12. How can they expect me to find the exact values, which means no decimals allowed, which means I'm not allowed to use my calculator, or at least that's not the proper answer, if it's not unit circle? What's so special about where it came from? Can I use the unit circle for that? Oh, who are these guys? Unit circle
Oh my.
people. Oh, so I can solve the non-unit circle person by figuring out that he's the combination or the operation, the sum of two unit circle people. Oh, sweet. Let's distribute sin.
No.
No. Are you going to want to do it? Yes. Can you do it?
No,
No,
yes.
because this is a sign of u plus or minus v. More specifically, a u plus v. The only legal way to distribute, it's not distributing. The only legal way to rewrite, so Sophia, here you go. It gave me this, but I can't proceed forward until I look at it like this. But I can't do this until I break it down. What does sine of u cosine of v mean? Sine of the first times cosine of the second. Sine, the signs stay the same, plus. And then cosine of the first and sine of the second. Now, are some of you going to be like, you're going to be kidding me now? Yes. Because will this take a little bit of work to figure out who sine is of this guy and who cosine is of this guy? Yikes. And who cosine is of this guy and who sine is of this guy? Are you going to have to like review unit circle stuff? Sine is stay the same. Now, the sine is positive in the second quadrant, cosine is negative in the second quadrant. But in the first quadrant, they're both positive. Now, end up with root 6 over 4 minus root 2 over 4, which is root 6. Now, here's the crazy thing. What would happen if you plugged in radian mode sine of 11 pi over 12 into your calculator? You would get an approximate decimal rounded answer, an answer that you could round, but it would be the exact same, well, its exact form would be root 6 minus root 2 over 4, which you can't simplify more, sadly. I know. But he's under square roots and he's not, and I can't pull a 2 out because they're under square roots. And I can't combine because they're not like terms. There's a lot of like illegal past math stuff that might kind of come and haunt you. But there's a lot more where this comes from. This is kind of like the beginning where you're not really verifying, you're not really simplifying, you're not really solving, you're not really doing 5-1, 5-2, or 5-3. You're just realizing why this formula is necessary. because it makes possible some previously impossible stuff. Like, we can't do 12ths unless we can rewrite it as units, okay, guys? Then with the new formula, we can. Anyway, all that to say, should you kind of like start playing in homework tonight? Maybe. But what's the most important thing to actually like get your mind wrapped around?
Quizlets.
You're gonna have to have your formulas memorized. But when you do your homework, what should you not be worried about? Recalling your formulas. Like, have the formulas in front of you, maybe write it out, maybe for all of chapter 5, make one huge page. That way, as you're doing homework, as you're doing the practice test, or the test review, or as you're doing notes in class, you can have those formulas and be looking at it, because you get to do that in the test. Does that make sense? So if I were you, I'd make a big old formula page tonight, or a big old formula flashcard. That way you can like bring it to class, use it in class, use it in your homework, because you're going to be able to be looking at them, but you also need to be studying. Good deal?
Yes.
Okay. I guess that's it. Although I'm not going to minute early. You could have kept going, huh? Well, let's see. I have 2 kisses left. What did I use them for? Is the unit circle still going to be important? Yes. So, how about, ready? First hand I see, I can give me something easy. Let's do cosine 2 pi over 3.
One over 2.
Oh, you're so close. Why is it? Negative. That's the negative, and this is the 1/2.
Thanks.
Why is it negative, Sophia?
It's in the second quadrant, which is
Sine's positive, not cosine. Good, but why is it 1/2, Jaden?
I just did the chart.
Exactly. You did cosine is the second row, and he did 3, 2, 1, 1/2. So let's review our unit circle. Let's figure out with our formulas how we're going to study them, how we're going to do them. Let's maybe make a big old formula page. You can use it on any problems that we do in class or for